Okay, so this is an experiment on the parallel network where we have a parallel connected resistors that we're going to test. So on the bench we have a digital voltmeter which we have used on our previous experiment, which is the series connected resistors. We have an analog multimeter, then two sets of power supply. One is a variable power supply and a fixed voltage power supply. We have also on the bench is a breadboard with resistors connected. So these resistors are connected in parallel, as you can see. The first resistor that we have is a 390 ohms resistor. The second one is a 1 kilo ohm resistor. And the third one is a 2.2 kilo ohm resistor. So these resistors are connected in parallel, as you can see. And the terminals, the terminals, the left terminal is connected to the green terminal post, while the other side is connected to the red terminal post, where we will be going to attach the power supply. Okay, so we measure the voltage output of this power supply, which is the fixed. So in this case, we're going to use the analog multimeter this time. So first, we set the analog multimeter to the highest voltage, and that is the 250 volts DC, and we attach the terminal of the power supply to the probes of the multimeter. Okay, so first we take note of the setting, and what happens is that the deflection is very little, so we move down the setting to 50 volts. Okay, then we look at the scale. Okay, that's it. So as you can see, we set the selector knob to 50 volts. So the scale that we're going to use is this 50 volt mark. This 50 volt mark. And the needle pointed on this scale. So this is the 10 volt mark, while this one is the 20 volt mark. We adjust this camera first so that we could not see the reflection of the needle on the mirror. Okay, that's it. So now we read the scale. Okay, so that's the output of the power supply. We connect now the power supply to the network, to the resistors. Okay, so it's now powered up. Then we were asked to get the reading on the terminal voltage of the resistors, the network. So we insert the negative probe, and then second we insert the positive probe on the terminals. Then again we look at the multimeter. It's set to 50 volts. Then we read the scale. Again, that's in 50 volts, meaning we're going to read on this scale. From this 10, this is the 20. So we read the scale here. Then we read now, we try to measure the voltage on the first resistor. So let me first transfer the probe to the terminals of the resistor. There you go. So it's now transferred. Then we now go back to the multimeter. Again, it's set to 50 volts, and we read the voltage drop on the first parallel resistor, first shunted resistor. Okay, then we transfer the probe again on the next resistor. Okay, that's already on the second resistor, the probe's on the second resistor. And now, again, the voltmeter set to 50 volts for the maximum deflection. And then we also read we now read the voltage on the second resistor on the same scale that we've been using. So finally, for the voltage reading, we transferred again the probes to the third resistor terminals. That's it. For the 2.2 kilo ohm resistor, and read the voltage on the scale of the multimeter. Again, it's set to 50 volts, so we'll be using the 50 volt scale, the ones that we've been using before. Okay, so that's the voltage reading of the parallel circuit. Now we are going to measure the current, the total current consumed by the network. So what we're going to do is first to set the multimeter to current measurement. So in this case, we're going to set it to 500 milliamperes DC. And then, as we know, in order for us to measure the total current of the load, we have to connect the ammeter in series. So for me to connect the multimeter or the ammeter in series, I have to break this circuit first. I have to transfer this one, this hole, and then I insert the probes of the multimeter. Okay, so this is the connection. So I have inserted the multimeters. Supposed to be, this one is coming from the power source, and this is the terminal of the resistor. So I break it and inserted the ammeter here. So we're at the 500 milliampere range of the multimeter. So going back to the scale, what we're going to do is to refer to this calibration, the 50. So for us to have a 500 milliampere reading, we have to multiply whatever we read on this scale, we multiply it by 10. So in this case, this is the 10 and this is the 0. So we're going to read what is the current consumption of the network. Okay, so whatever the reading is, we multiply it by 10 to get the actual milliampere current, or the current that's the resistors is consuming. Okay, so that is the total current consumed by the resistor network. So we put back the circuit. We connect again the we pull out the ammeter, connect back the circuit, the original configuration, and then the next thing to do is to measure the current consumed by the first resistor, and in this case, this is the 390 ohm resistor. So what we do, we insert again the ammeter in series with this resistor. So what I'm going to do is to pull out this jumper wire, and instead of a jumper wire, I insert my probes of my ammeter. Okay, and I read the current flowing through the resistor. As you can see, it's very small. So what I'm going to do is to make or to set the ammeter to a higher range, or I mean to the smaller current. Then check the reading. Still very small. I go back. So this must be very small. So instead of that, I'm going to use the digital ammeter. So what I'm going to do is transfer this accessory, probe accessory, so that it would be more easy for me to measure the current using only one hand, since I'm holding the camera now. Oops, sorry. Okay, and then set the digital multimeter to the right probe connection, and then also set the reading to current. Okay, that's it. Then I insert now again the probes to in series with the first resistor. Okay. Then I try to read what is shown on the digital multimeter. So using the digital multimeter, it's much easier compared with the analog, but of course we have to be trained how to use the analog multimeter. Okay, so the next thing to do is to measure the current consumption of the second resistor. So what I'm going to do is to pull out again the ammeter, put back the jumper wire on the first resistor, and pull out the jumper wire on the second resistor and insert the ammeter. So this time we're using the digital multimeter, which is set to measure current, and we take a look at the reading. And then we measure the third resistor. So what we're going to do is to pull out again the probes of the ammeter on the second resistor, and reinsert the jumper wires that we have taken out a while ago. Okay. And then insert the multimeter or the ammeter on the third resistor in series with the third resistor. So what we're going to do is to pull out the jumper wire, and instead of that we insert the ammeter. So what we have just inserted the ammeter, and we try to read what's the current consumption of the third resistor, which is the 2.2 kilo ohm. Okay, so that's the parallel circuits, the current consumption and the voltage readings of the parallel resistor.